Hi dear, it is beautiful working with numbers, but it may get a little tedious when numbers get so large or so little. Working with numbers like 10, as in 10 boxes, 50, as in 50 kilograms, 2, 1, and even 0 is simpler. But when numbers get so big, like the number of stars in the Milky Way, which is about 400 billion stars, or the diameter of the Milky Way, which is about 1 quintillion kilometers, you see that you have so many digits to handle. What about working with a number so small, like the diameter of a bacteria cell, which is as small as 0.0000001 meters, or the diameter of a ribosome, which is 0.0000002 meters. You can also see that you're faced with too many digits and you may make mistakes handling all these digits. So, scientists developed a system of writing these numbers in a more compact way with less digits and greater ease of manipulation and called it the standard form. I bet you must have seen numbers written like this. This is an example of a number written in standard form. The standard form is generally written as A times 10 raised to the power B, where A is a number between 0 and 10, and B is an integer. We can write the diameter of the Milky Way in standard form, and you'll see how handy it becomes. The major thing we do in writing a number in standard form is to move the decimal point towards the first significant digit and count the steps moved by the decimal point. The number of steps moved is indicated by the value of the index of 10. Remember that since this number is a whole number, the decimal point is at the end of the number, that is, after the last 0 going from left to right. We are going to be moving the decimal point towards the first significant digit. In this case, the first significant digit is 1, so count as we move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. We have 18 steps, meaning the Milky Way is really big. The number now becomes 1.0 up until 18 zeros. Depending on the accuracy, it is advisable to write the first part in 3 significant figures to facilitate handling. So we have 1.00. But 1.00 is not equal to 1 quintillion. That is why we will compensate for the lost digits by multiplying 1.00 by 10 raised to the power 18, since we moved 18 steps to the left. So the diameter of the Milky Way is 1.00 times 10 raised to the power 18 kilometers. We can as well write 0.0000002 meters, the diameter of a ribosome, in standard form. Remember that our duty is to move the decimal points in steps towards the first significant figure and counting the steps as we move. This time around, we move the decimal point to the right towards 2, which is the first significant digit, and stop just after 2. Let's count as we move. 1, 2, 3, 4, 5, 6, 7, 8. The number is now 2.0. In this case, because we moved the decimal point 8 steps to the right, we are going to multiply 2.0 by 10 raised to the power minus 8. The index of 10 in this case is negative because we moved the decimal point to the right. The final answer after writing 0.0000002 meters in standard form is 2.0 times 10 raised to the power minus 8. In summary, the standard form is A times 10 raised to the power B. Also, the index of 10 is negative when the decimal point is moved to the right, and positive when the decimal point is moved to the left. Studies have said that the number of red cells in an adult human body is up to 30 trillion. You can go ahead to write this number in standard form. I know you're up to the task.